Hello everyone, this is Sir A. In this video lecture, I will be covering the concepts of work, power, mechanical energy, potential energy, and kinetic energy. Let's start by imagining a series of scenarios. Let's say that you are on your way to the gym when you walk past an elderly man pushing a loaded cart along the rough pavement. You decided to help the old man in pushing the cart until you reach the gym. On the gym windows, you admire a poster of Heidelin Diaz successfully doing the golden lift that won her the Olympics medal. As you pass the indoor basketball court, you notice your friends suspended in midair after releasing a ball from the 3-point lane. Now, what do all of these events have in common? All of them are examples of work. What is work exactly in physics? We say that work is done on an object when the force applied to it caused it to be displaced, or in other words, to change its original position. In the previous examples, the old man does the work as he exerts applied force to move the cart. Meanwhile, Heidelin Diaz also does work on the barbell as she lifts it up from the ground. Work then depends on two variables, force and displacement. Work is in fact computed by getting the product of force and displacement. If Newton, the unit of force, is multiplied by meter, the unit of displacement, the combination of the units is joules. If force is exerted on an object, but it did not cause any displacement, we say that there is zero work done on that particular object. An example of this is a person doing wall push-ups. No matter how much they push against a solid wall, they will not be able to move it. However, it's surely a different story if a giant wrecking ball is used to demolish the wall or the building. Many types of forces can be present in an object all at once, and in some instances, you will be asked to get the amount of work done by each of the forces. Let's take a look at these two images. On the photo on the left, it is the applied force that is responsible for displacing the weight upward. We then say that the applied force does work on the barbell. Meanwhile, on the image on the right, Heidelin let drop the barbell to the ground. It is then displaced downwards. This is due to the gravitational force of the Earth, which in the second example is the doer of the work. Work generally falls under two categories. The first one is when work is done against another force. For example, an archer is doing work on the bowstring by pulling against its elastic forces. Heidelin is also doing work against the downward pull of the gravity as she tries to lift the heavy barbell upwards. Aside from work being done against another force, work can also be done to change the velocity of an object. For example, work can be done on a car to accelerate it or to slow it down. Under what category is climbing up the top of the stair belong to? When we climb upstairs, we are lifting our weights up and therefore working against gravitational force. So this work belongs under the first category.